Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Azwar Azhar bin Muhammad Yusof. Sekarang ni saya akan membuat presentation mengenai subjek kod EBMV 3103, subjek name Air Conditioning and Mechanical Ventilation System. Principle of ventilation. Ventilation system may be classified according their ability to supply and withdraw air from the rooms ventilated. It is common to differentiate between the shortcut principle, mixed principle, displacement principle, and piston principle. The shortcut principle. The ventilation system is shortcut when the make-up air is withdrawn from the room before it has been in the people operating zone. A shortcut will reduce the efficiency of the ventilation system, has no mission, and is in general avoided. Shortcut principle. Sekiranya anda lihat di sini adalah udara yang masuk dan udara itu terus sahaja keluar. Maksudnya dia tidak melalui ruangan dalaman sesuatu tempat itu. Itu yang dipanggil shortcut principle. Dia masuk dan terus keluar. Dia tidak lalu ke kawasan-kawasan yang lain. Seterusnya, the mixed principle. With a ventilation system based on the mixed principle, make-up air is supplied to the room with high speed and or local fans are used to mix the air in the room to an homogeneous mass. The mixed principle is suited for ventilation, cooling, and heating system, where homogeneous temperature is in the room are required, where homogeneous pollution concentrate in the room are required. Kalau anda lihat, ini adalah contoh mixed principle di mana udara masuk dan dia melalui segenap ruang dalam satu kawasan itu sebelum ia keluar. Itu yang dipanggil mixed principle. The displacement principle. With the displacement principle, heat and pollution is transferred from the resident zone close to the floor to the ceiling where it's evacuated through the outlet system. Make-up air is supplied with low velocity very close to the floor. The supply air is normally colder than the average air in the residence zone. The evacuated air close to the ceiling is warmer than the average air in the residence zone. Activities in the room, people and machine create convection airflow from the floor to the ceiling. Heat and pollution are transferred out of the residence zone. Heat like supply under the ceiling have limited influence of the temperature in the room. The cooling temperature of the air supply limited to some degrees under the temperature in the residence zone. The pollution concentration in the residence zone is limited. The displacement ventilation system is suited for ventilation and cooling system. The system is not suited for heating. Seterusnya adalah displacement principle example. Ini adalah displacement principle example. Udara masuk, lepas tu ada kawasan clean zone, dia menolak udara ke polluted zone dan akhirnya dia keluar. The piston principle. In a ventilation system based on the piston principle, the supply air moves through the room like a piston. The piston principle can be regarded as an extreme variant of the displacement system with a minimum of turbulence in the airflow passing through the room. Sekarang ni anda lihat udara masuk ke dalam sesuatu ruang itu dan dia melalui semua ruang Maksudnya dia tidak seperti cycle dan dia direct terus keluar ke satu ruang yang lain. Tapi keadaan ni dia memenuhi semua ruang. Function of ventilation. Ventilation move outdoor air into a building or a room and distribute the air within the building or room. The general purpose of ventilation in building is to provide healthy air for breathing by both diluting the pollutant originating in the building and removing the pollutant from it. Sekarang kita lihat principle of air conditioning. Heat transfer. Heat is a form of energy. Every object on Earth has some heat energy. The less heat an object has, the colder we say it is. Cooling is the process of transferring heat from one object to another. When an air conditioning system cools, it is actually removing heat and transferring it somewhere else. This can be demonstrated by turning on a spot cooler and placing one hand in front of the cool air nozzle and the other over the warm air exhaust. You will feel the action of the transfer of heat. Sensible and latent heat. There are two forms of heat energy, sensible heat and latent heat. Sensible heat is the form of heat energy which is most commonly understood because it is sensed by touch or measured directly with a thermometer. When weather reporters say it will be 90 degrees, they are referring to sensible heat. Latent heat cannot be sensed by touch or measured with a thermometer. Latent heat causes an object to change its properties. For example, when enough latent heat is removed from water vapor, steam or humidity, it condenses into water liquid. If enough latent heat is removed from water or liquid, it will eventually freeze. This process is reversed when latent heat is added. Change of state. An object that changes from solid to a liquid or liquid to vapor is referred to as a change of state. When an object changes state, it transfers heat rapidly. Humidity. Moisture in the air is called humidity. The ability of air to hold moisture directly related to its temperature. The warmer air is, the more moisture it is capable of holding. Relative humidity is the percentage of moisture in the air compared to the amount of moisture it can hold. A moisture content of 70 degrees Fahrenheit air with relative humidity is lower than 80 degrees Fahrenheit air with 50% relative humidity. When the humidity is low, sweat evaporates from your body more quickly. This allows you to cool off faster. High humidity conditions do not allow sweat to evaporate as well because the air is at its maximum capacity. Humidity is also a form of latent heat. When air contains more humidity, it has more latent heat. AC system perform 4 basic functions. 1. Maintain room cleanliness, control of airborne particles, dust and microorganisms is performed through air filtration using high efficiency particulate air (HEPA) filters. 2. Maintain room pressure delta P. Areas that must remain cleaner than surrounding areas must be kept under positive pressurization, meaning that air must flow be from the cleaner area toward the adjoining space through doors or other opening to reduce the change of airborne contamination. This is achieved by the HVAC system providing more air into the cleaner space that is then is mechanically removed from the sump space. 3. Maintain space moisture with relative humidity. Humidity is controlled by cooling air to dew point temperature or by using desiccant humidifiers. Humidity can affect the efficiency and stability of drug and is sometimes important to effectively mold the tablets. Controlling the moisture content of the environment is also important in minimizing the potential for microbiological growth on clean room surface. 4. Maintain space temperature. Temperature can affect production directly by impacting chemical or biochemical reaction or indirectly by fostering growth of microbial contaminant in the process or on workers. Refrigeration basic principle applies on all systems, whether it's the smallest water cooler to largest walk-in freezer that ever built. Freon gas or the refrigerant absorb heat inside the areas to be cooled in the evaporator unit and transfer that heat to the refrigerator condenser at exterior. The refrigeration basic principle is that with the aid of a heat pump, the refrigerant is being compressed to the condenser and capillary tube, thus increasing its temperature 50 to 60 degree and pressure 7500 kPa in the refrigerator being cooled down by the condensing unit to 32 degrees C depending the existing ambient temperature. Upon entering the evaporator unit, the gas expanded and vaporized due to sudden enlargement of the evaporator tube cross-section, eventually dropping its pressure to almost atmospheric value 120 kPa and temperature from 32 degrees to minus 24 degrees. Heat absorption takes place from the evaporator and being pumped out by a heat pump to the condenser, where being transformed from cool vapor to liquid state with higher temperature and pressure, thus completing the heat transfer cycle. Theoretically, after the cycle, the amount of refrigerant will remain contained in the system. When leakage occurs in the closed circuit, then efficiency of the refrigerator will gradually diminish till it stops cooling. By then, it requires servicing to be done by a qualified technician to locate its leakage or part that are not. Okay, now we look to the typical domestic refrigerator cooling system. As we look is number 1 is heat pump or compression. Number 2 is suction pipe or low pressure side with non-return valve. Number 3, liquid exit going to condensing unit with non-return valve. Number 4, water collector during defrosting process will gradually dries out. Number 5, freon or refrigerant charging point. Number 6, condensing unit, usually in the form of serpentine tube with electro-welded grill for effective ambient heat transfer. Number 7, vacuum application point to remove impurities and humidity prior to refrigerant charging. Number 8, capillary tube act as an orifice where inside diameter and length is being calculated to deliver the right flow of liquid to the evaporator unit. An alternative for capillaries is expansion valve for large refrigerant and particular refrigerator unit. Number 9, evaporator or collector unit usually in serpentine tube or plate or fusion bonded aluminum plate evaporator. Serpentine tube on plate evaporator is widely used in refrigerator and freezer. Tube is in aluminum or copper. Copper has more heat transfer coefficient, but it's heavier and more expensive compared to aluminum, which is lighter. Aluminum tube on plate evaporator or absorber can improve the heat transfer coefficient like copper by just increasing the thickness of the aluminum plate. And number 10, accumulator usually in copper or aluminum. Refrigerants are used in building for heating, ventilation and air conditioning HVAC system, to provide cooling for refrigeration, to provide cooling for industrial process. They provide cooling in a process that is essentially the same as that unit used in domestic fridge, based on either compression or absorption. In compression system, a liquid refrigerant with a low boiling point absorbs heat from the body that is being cooled and boiled in a evaporator to form a gas. The resulting gas is then compressed, which increases its temperature further. The gas is then condensed, releasing its latent heat, which is rejected. The process then repeats. The transfer of heat energy. The heat source for our planet is the sun. Energy from the sun is transferred through space through the Earth's atmosphere to the Earth's surface. Since this energy warms the Earth's surface and atmospheres, some of it is or become heat energy. There are 3 ways heat is transferred into and through the atmosphere: radiation, conduction, and convection. Well, let we see what is radiation, conduction, and convection. Radiation. If you have stood in front of a fireplace or near a campfire, you have felt the heat transfer known as radiation. The side of your body nearest the fire warm, while your other side remain unaffected by the heat. Although you are surrounded by air, the air has nothing to do with this transfer of heat. Heat lamps that keep food warm work in the same way. Radiation is the transfer of heat through space by electromagnetic radiation. Most of the electromagnetic radiation that comes to the earth from the sun is invisible. Only a small portion comes as visible light. Light is made of waves of different frequencies. The frequency in the number of instances that a repeated event occurs over a set time. In electromagnetic radiation, its frequency is the number of electromagnetic waves moving past a point each second. Our brain interprets these different frequencies into color, including red, orange, yellow, green, blue, indigo, and violet. When the eye views all these different colors at the same time, It is interpreted as white wave from the sun, which we cannot see, are infrared, which have lower frequencies than red, and ultraviolet, which have higher frequencies than violet light. More on electromagnetic radiation. It is infrared radiation that produces the warm feeling on our bodies. Most of the solar radiation is absorbed by the atmosphere, and much of what reaches the Earth's surface is radiated back into the atmosphere to become heat energy. Dark-colored objects such as asphalt absorb radiant energy faster than light-colored objects. However, they are also radiate their energy faster than lighter colored objects. Conduction. Conduction is the transfer of heat energy from one substance to another or within a substance. Have you ever left a metal spoon in the pot of soup being heated on a stove? After a short time, the handle of the spoon will become hot. This is due to transfer of heat energy from molecule to molecule or from atom to atom. Also, when objects are welded together, the metal become hot, the orange to red glow by the transfer of heat from and up. This is called conduction and is a very effective method of heat transfer in metal. However, air conduct heat poorly. Convection. Convection is the transfer of heat energy in a fluid. This type of heating is most commonly seen in the kitchen with a boiling liquid. Air in the atmosphere acts as a fluid. The sun radiation strikes the ground, thus warming the rock, and the rock temperature rises due to conduction. Heat energy is released into the atmosphere, forming a bubble of air which is warmer than the surrounding air. This bubble of air rises into the atmosphere, and as it rises, the bubble cools with the heat contained in the bubble moving into the atmosphere. As the hot air mass rises, the air is replaced by the surrounding cooler, more dense air, what we feel as wind. This movement of air mass can be small in a certain region, such as local cumulus cloud or large cycle in the troposphere, covering large sections on the Earth. Convection currents are responsible for many weather patterns in the troposphere. As we look, this is an example of the radiation. You see the sun transfer the heat to the earth by radiation, and the ground heats hot, and the hot air become conduction, and the warm air rise is a convection. Air conditioning and mechanical ventilation system. The purpose of an air conditioning and mechanical ventilation system is to maintain comfort condition in the air-conditioned space in respective of the outdoor ambient condition. Comfort condition usually refers to a specific range of temperature, relative humidity, cleanliness, and distribution of air meet the comfort requirement of the occupant in air-conditioned space. For a tropical country like Malaysia, outdoor ambient temperature is generally higher than the comfort temperature of conditioned space. Therefore, air conditioning chills water systems are required to operate throughout the year to maintain the comfort condition in the commercial building, hotel, hospital, industrial building, and etc. Central air conditioning plant in the single largest energy consumer that consume about 60% of the total energy consumption of a typical commercial building. Whilst selection of the component of the central air conditioning plant and energy smart control and operation strategies may contribute to the significant energy and cost saving. Vapor compression refrigerant cycle. We all know from experience that heat flow naturally from high temperature to low temperature space without requiring any device. However, the reverse process of transferring heat from low temperature conditioned space to the high temperature outdoor ambient air requires a special device called air conditioning and mechanical ventilation system. The air conditioning machine, commonly known as chiller, are cyclic device. The working fluid used in the air conditioning cycle is called refrigerant. R123 and R134A are two commonly used refrigerant in air conditioning system. Ozone depletion potential ODP of R123 and R134A are 0.02 and 0 respectively. However, global warming potential GWP of R123 and R34 are 77 and 1430 respectively. Based on Singapore Green Mark criteria, ODP of refrigerant should be 0 or GWP should be less than 100. Both R123 and R34 are meet Singapore Green Mark criteria. CFC refrigerants such as R12 and R22 are not environment friendly. Therefore, they are phased out and should not be used in air conditioning system. Manufacturers of the air conditioning system also carefully consider other properties of refrigerants such as efficiency, toxicity, atmospheric life, operating pressure, cost, and etc. The most frequently used air conditioning cycle is the vapor compression air conditioning cycle, which consists of four main components. A. Compressor, B. Condenser, C. Expansion valve, and D. Evaporator. As we look, this is the arrangement of the component and the variation of pressure and specific enthalpy of the refrigerant and at different stage of the air conditioning cycle are shown in figure 1.1. Heat rejection, condenser, motor, compressor, evaporator, expansion valve, pressure over specific enthalpy. This is the cycle of the air conditioning. Function of main component, compressor. The function of the compressor is to increase the pressure of refrigerant vapor from evaporator pressure, 0.1, to the condenser pressure, 0.2. The compressor is driven by an electric motor using an appropriately designed gearbox or transmission system. Compressor receives refrigerant as a saturated or slightly superheated vapor at low temperature and pressure, 0.1, and discharge as superheated vapor at relatively high pressure and temperature. This is 0.1, this is 0.2. The transfer, the compressor compressed air from evaporator through the condenser. Condenser. The condenser is a heat exchanger. The function of the condenser is to reject heat from the refrigerant vapor to the surrounding ambient air or the cooling water known as condenser water. Superheated refrigerant vapor of relatively high pressure and temperature, 0.2, enter the condenser, reject latent heat of condensation and leave as saturated or slightly subcooled liquid refrigerant of high pressure and temperature, 0.3. Expansion valve. The function of the expansion valve is to reduce the pressure of liquid refrigerant from the condenser pressure, 0.3, to the evaporator pressure, 0.4. Same as any other liquid, boiling temperature of liquid refrigerant drop due to the reduction of refrigerant pressure after the expansion valve, 0.4. Low pressure liquid refrigerant partly evaporates, change phase from liquid to vapor by absorbing latent heat of vaporization from the liquid refrigerant itself and enter the evaporator as a liquid vapor mixture. Point 4 of low pressure and temperature. Evaporator. Same as condenser, the evaporator is also a heat exchanger. In the evaporator, the liquid refrigerant absorbs heat from the surrounding air or circulating water known as chiller water. Partially evaporated liquid vapor mixture of refrigerant of low pressure and temperature. Point 4. Enter the evaporator. Absorb latent heat of vaporization from the surrounding air or chill water and then leave as saturated or slightly superheated refrigerant vapor of low pressure and temperature. Point 1. The cycle is complete as the refrigerant leave the evaporator and again enter the compressor. As we look, evaporator going into compressor, compressor compress the air from the evaporator and enter the condenser. And then expansion valve take from the condenser and transfer it to evaporator and the cycle is complete. Industry Code of Practice on Indoor Air Quality. The Industry Code of Practice also emphasizes on the duties of an occupier of a place of work to person other than his employees stipulated in Section 18 of OSHA. An occupier is a person who has the management or control of the space of work. This duty is owed to persons who are not his employees but go to their premise to carry out work. Compliance to this industry code of practice can be used as evidence of good practice in a court. This industry code of practice has been drawn up to ensure employees and occupants are protected from poor indoor air quality that could adversely affect their health and well-being and thereby reduce their productivity. It is the general duties of employer and self-employed person to their employees as stipulated under Section 15 of Occupational Safety and Health Act 1994 OSHA, while Section 17 of OSHA stipulated that it is also the general duties of employers and self-employed person to person other than their employees. The Industry Code of Practice also emphasizes on the duties of an occupier of a place of work to person other than his employees stipulated in Section 18 of OSHA. An occupier is a person who has the management or control of the place of work. This duty is owned by person who are not his employees but go to their premise to carry out work. Compliance to this industry code of practice can be used as evidence of good practice in a court. Ashray 1999. Ventilation for Acceptable Indoor Air Quality, American Society of Heating, Refrigerating and Air Conditioning Engineers. Ashray Standard 62.1/2007. The purpose of this standard is to specify minimum ventilation rates and other measures intended to provide indoor air quality that is acceptable to human occupants and that minimize adverse health effects. This standard is intended for regulatory application to new building, addition to existing building, and those change the existing building that are identified in the body of the standard. The standard is intended to be used to guide the improvement of indoor air quality in existing building. USECHH regulation. Occupational safety and use and standard of exposure chemical hazardous to health regulation 2000. USECHH regulation was made to provide a legal framework to control exposure of chemical hazardous to health at workplace. This regulation is to set a standard of exposure of chemical hazardous to health to the worker at workplace. If chemical is not listed in the Schedule 1 or 2 but was classified as hazardous under class regulation, this chemical will cover under USECHH regulation if it is used at workplace. Occupational safety and health use and standard of exposure chemical hazardous to health regulation 2000 USECHH regulation. That's all from me, Muhammad Azwar Azhar bin Wan Yusof. Thank you for listening.